Welcome back, everyone. This is part 3 in our series on NLI. This is our chance to start getting a little introspective and think more about developing truly robust systems. So our topic is going to be dataset artifacts and adversarial testing. I'm pleased to report that a lot of the discussion in this area actually traces, in the NLI context, to a course project for this class. In 2016, Land and Kesselman observed that for NLI, hypothesis-only models were surprisingly strong. And what I mean by hypothesis-only model is that these are models that literally throw away the premise text and reason entirely in terms of the hypothesis. So to the extent that models can succeed, despite having no information about the premise, we might really worry about whether we're solving the task we think we're solving, because after all, NLI is supposed to be about the reasoning relationship between premise and hypothesis, and you would not expect it to be successful if you were given only the hypothesis. But what Land had observed is that these models were surprisingly strong. Subsequently, and I think partly independently, a number of other groups made the same sort of observation about a variety of NLI benchmarks. And that kind of leads us to the conclusion that, at least for SNLI, averaging across a whole lot of different systems, hypothesis-only baselines are typically operating in the range of about 65 to 70% accuracy. Again, that's eye-opening because chance performance would be 33%. And this is showing us that there is some unusual bias in the hypothesis that is allowing us to neglect the premise and still have a lot of predictive capacity. The reason for this is likely to due to what we're going to call artifacts in these data sets. And just for a few examples here, we can observe that specific claims are likely to be premises in entailment cases, and correspondingly general claims are likely to be hypotheses in entailment cases. Just think at the lexical level, if you have a pair like turtle and animal, where you have a very specific term in the premise and a very general term in the hypothesis, that's an entailment relation. And if you did just drop off the premise and looked only at the hypothesis animal, you might still have a pretty good guess that that's going to be an entailment case in virtue of the generality of the second term. And relatedly, specific claims are likely to lead to contradiction. A common strategy for creating a contradiction pair is to just make sure you have two sentences that exclude each other in virtue of being very specific. So it's in virtue of patterns like this that a system denied the premise can nonetheless succeed at about 65 to 70% accuracy. Let's get a little more precise about what we mean by an artifact, because I think we need to think about this in a nuanced way. So my definition is that a dataset artifact is a bias that would make a system susceptible to adversarial attack, even if the bias is linguistically motivated. And let me give you an example that brings out the nuance there. Consider negated hypotheses tending to signal contradiction. This is a very natural thing linguistically. If you give me a sentence like "the dog barked," and you ask me to construct a contradictory sentence, it's very natural for me to say "the dog didn't bark" by simply inserting a negation. So it's not a surprise that this happens. It's linguistically motivated. Negation is our best way of establishing the relevant kind of connection. However, here's the reason that this is an artifact. We could easily curate a data set in which negation correlated with the other labels, but nonetheless, this led to no human confusion, because humans are not really operating at this general level of a data set bias. They're thinking about individual examples and what they mean. But we know that our systems are going to be very sensitive to the distributions of things in their training data. And that's the sense in which we can be adversarial in this way and expose that a system has overfit to a certain kind of regularity. Here are some known artifacts. This is by no means exhaustive, but I think this will give you a sense for the kind of things that you want to look out for in NLI context, but also generally in dealing with problems in NLU. So it's been observed that these data sets contain words whose appearance nearly perfectly correlates with specific labels. And what I mean here is just randomly chosen words like cat and dog. The reason for this is probably that crowd workers were producing a lot of examples, and they fell into a pattern of making specific lexical choices, and that created a spurious bias for one label or another. Entailment hypotheses overrepresent general and approximating words. We've seen that that's systematic in terms of the linguistic patterns, but it's an artifact because the world needn't be this way for humans to succeed in making their predictions. Neutral hypotheses often introduce modifiers. This was a way that workers found to create statements that excluded each other with simple modifications. Contradiction hypotheses overrepresent negation. We've seen that, and that makes sense. And neutral hypotheses tend to be longer. And that last one is yet again another case where that's the sort of regularity that our systems are going to be very good at picking up on, but that humans will probably not make direct use of in making predictions of their own. And in that way, we can easily leverage this observation to create an adversarial setting for one of our models where humans succeed at the task, but our models suffer because they're cued into the wrong aspects of the underlying problem. To close this out, I just want to emphasize that artifacts are discussed a lot in the context of NLI. I think that's because a bunch of big benchmarks appeared and people did a lot of probing work to understand them. But it does not follow that NLI is the only task where the data sets have artifacts. In fact, I would venture that every task that we work on has associated data sets that suffer from artifacts. Here I've given you a sample from prominent NLU problems where people have found artifacts that are similar to the ones that I just covered for NLI. And the overall lesson is clear. Whatever problem you're working on, you should think critically about your data and how idiosyncrasies in that data might be affecting system performance and creating a distance between what you think you're doing in terms of problem solving and what your system is actually doing. And one way we can expose this is via efforts involving adversarial testing. We're going to have a whole discussion of this later in the quarter, but I do want to plant the idea here. In adversarial testing, we're going to take standard NLI examples like this and modify them in ways that expose that systems have surprising gaps. So a prominent early example of this is this wonderful paper by Glockner et al. Called Breaking NLI. What they did is very simple. We're going to operate with actual SNLI examples. Here we would start with the premise, a little girl is kneeling in the dirt crying, and a little girl is very sad, which is an actual SNLI example with the entailment relation. We'll fix the premise. What they did to create their adversarial data set is simply swap out sad for unhappy. That is, create pairs that differ only according to the synonyms that they use. This is only mildly adversarial, but you can see why this might be difficult. Unhappy contains a negation, and we might have a hypothesis that systems will then predict contradiction because they've overfit to the association of negation with contradiction. And that's exactly the kind of pattern that Glockner et al. Found. And the overall takeaway here is that these systems that we've developed are not behaving systematically in the sense of cognitive science. They're not behaving according to the kinds of underlying intuitions that human language users have. Their patterns of errors are more surprising and idiosyncratic, leading us to worry about their true capacity to generalize. Let me show you one other example. This is from Ni et al., and it involves syntactic variations. So in this case, we'll take actual examples and fix the hypothesis, but now vary the premise. So this is one of their manipulations where they simply swap the subject and object. Our original premise is a woman is pulling a child on a sled in the snow. That entails a child is sitting on a sled in the snow. That's good. We would expect that if we modify the premise so that the subject is a child and the object is a woman, this would create the neutral label with respect to our fixed hypothesis. But perhaps unsurprisingly, Ni et al. Found that many systems were not sensitive to this change in the premise, revealing that they were mainly making use of the bag of words, so to speak, and not truly attuned to the syntactic structure. And that's so productive because that specific lesson might lead us to go looking for systems that are more sensitive to syntax and therefore would be not susceptible to this kind of adversary. And in that kind of productive back and forth, I think we can triangulate on even better systems for the next generation.